Hello everybody, welcome to another video. This one will be exploring the AP Micro Unit 3 concept of perfect competition. If this helps you in any way, which I truly hope it does, please feel free to like and leave a comment. So now I'm gonna get into the good stuff. So what are the conditions or the requirements for a firm to be considered perfect in perfect competition or a market? Well, so the market has to have free entry and exit for firms. So pretty much what this means is that firms can enter the market or leave the market at any time, whenever they want, or in terms that your teachers might say, they say there's no barriers to entry or there's no barriers to exit. Okay, two, product homogeneity. What this means is that all of the firms are producing the exact same product. So, for example, think of like maybe wheat. Your teacher probably used as an example farms. So wheat, for example, all farmers are producing the same wheat. There's not one wheat that tastes much different than a different type of wheat. Okay, now three, many firms. So what this means is there are many firms, like tens of thousands or thousands. There's a lot of firms in the market. Okay, four, the firms are price takers. Now, your teacher probably said something about a small market share. Well, what this means is that because there's so many firms producing the exact same products, each firm doesn't have a big control of the market, very, very small control. And so, what this means is that the market price is going to be set where each firm agrees or where like the demand meets the supply. And this is because if your firm charges an amount less than another firm, well, you would just be losing profit because buyers would buy pretty much the same amount from your firm. I mean, you wouldn't really have an advantage. Not many buyers would go to yours because there's so many firms. And this also means that if you charge a price higher than other firms, that no one would buy from your firm because why would they, right? If you can buy something for cheaper, why would you buy it for more, right? Okay. So what does the short run perfect competition graph look like? So I'm going to draw this out. Okay, so you have your axes. This one is quantity. The x-axis is most of the time always quantity. And then the y-axis is price or cost, whatever way you want to think about it. So we have what your teacher probably referred to maybe as Mr. DARP or MR equals AR, which equals demand, and this equals price. So this demand here, I want to talk about quickly. This demand here is not the market demand for the good, but it's rather the firm's demand. So how many people want from the specific firm, per se, if that's how you want to think about it. But pretty much what this means is these are all equal to each other, or you have Mr. DARP. I know I wrote it in a weird way where the D was over here. But I think what my teacher said is that this year they're going to start requiring that you write it like this instead of just saying Mr. Darp. So you do have to set them all equal to each other. Okay. And this is a horizontal line, which means that the firm's demand is perfectly elastic. Okay. So now we're going to have the marginal cost. So the marginal cost kind of looks like a check mark in a way. We'll do it like this, and label it MC, of course. It looks like this because this section where marginal cost is downsloping here is where the marginal product is upsloping. And then, of course, there's marginal or diminishing marginal returns, which you guys probably learned about. Um, and that's where marginal product is decreasing, and that's where the MC increases. So the up portion of this check mark. Okay, so the next part, let's draw this in a different color, is the average variable cost. Or yeah, we'll go with that one first. So the average variable cost is going to come like this. And for this example, swoop under, and then that's going to be the minimum. And then this would be A, V, C. Okay, so why is this like this? Well, the marginal cost, I know this is supposed to be an algebra-based class, but this is the best way to explain it. The marginal cost is I mean, it's similar to the derivative in calculus terms of the average variable and average total cost. So where the marginal cost intersects the variable cost and the total cost, which I'll draw next, the average variable cost and total cost, is where the minimum of those graphs occur. So as you can see, this is pretty much the minimum of the average variable cost where the MC intersects. Okay, now let's draw the average total cost. Now, that if the variable cost is the total cost plus the fixed cost, then the average total cost is going to be the average variable cost plus the average fixed cost. So it's going to always be higher than the average variable cost. Okay, so what does this look like? Well, it'll look like this, and then it'll get closer, and then, like I said, the MC will go through the minimum, and then it'll always get closer to the average variable cost, but they'll never touch to each other. Okay. And this is a little inaccurate because this space is greater than this space, which isn't really like good. I mean, that's not a good example. Um, but it gets the point across. Basically, you're saying that this is higher, right? The marginal cost goes through the minimum, and that's pretty much what we're looking for. Okay, and that is the short run graph. Now, for profit maximizing here, pretty much what you're going to do is what your teacher, I mean, you've probably heard this so many times by now, unless you're self-studying or something, which is completely understandable. You're going to find where MR equals MC. Okay, well, that's pretty simple if you look at the graph really, because you have your MR is this horizontal line, so you know it's going to be some point on this line. Then you have your MC here, and so where is it? Well, it's the point where they intersect, so it's here. So what the firm is going to do is produce at this quantity. They're going to produce this many units of the good, and they're going to produce at this price, which in perfect competition, a firm will always produce at the same price, no matter what the quantity is. So we'll call this price. So we'll just make it green. Um, and so to calculate this profit, what you would do is you would go to the price. We can say the price here is $20. And then you would go down to the average total cost, which this is kind of a bad way of showing it because the average total cost is so close to the marginal cost. But that's where you would go, and you would go across to the price line. I had to make it a little lower to show this here. And you would say ATC, and then whatever price that the ATC lines up with, we'll say it was 18 because it's so close to the price. Okay, so you have those two values. What do you do now? Well, let's say that Q here is 20. Okay, well, if you have average revenue is this, right? Well, that's not really a good explanation. So pretty much the profit is going to be the shaded box between price and average total cost. And why is that? Well, it's because price is how much a firm is going to be paid for their product, right? So that's how much gross revenue they'll be making each per unit, right? So here, if they sold one unit, it would be $20 in profit or in revenue, gross revenue, sorry. And then their average total cost would be $18. So that's their cost. So that would be $2. $2 of profit for one unit of the good. Now, if the good, or if at MR equals MC, they're selling 20 of the units, 20 units, well, 20 times 2 equals 40. So that's how much their profit would be in this example. Or what you could say is that profit equals P minus ATC times Q. And that's a general equation to do this. Okay, now let's move on. And I think next slide. Okay, yep, this is good. So when should a firm shut down? And this is in the short run. When should a firm shut down, or when should a firm continue producing if they're making a loss? And this is only if they're making a loss. Obviously, well, maybe it's not obvious, but if they're making a positive profit, they would want to continue producing either way. So let's draw a graph here. Um, okay, and I will make everything the same color because we just went over what these mean. Okay, and then here we're going to have marginal cost, and then average total cost, and then average variable cost. Okay, well, so here's where MR equals MC. So we can say this is quantity, the quantity that's produced, and this is the price that's produced. Let me change to a different color. And so what's the loss here? Because basically how you know it's a loss is if the average total cost is greater than the price, then that will be a loss. So you can identify this as a loss. So the loss here will be this line, and then the average total cost price, or the average total cost, and then the loss would be this box. Okay, well, so if you guys remember, would a firm shut down or continue producing in this case? I'll give you a few seconds. Okay, well, here a firm would shut down. Why would a firm shut down here? Well, as you can see, where MR equals MC, the average variable cost is greater than the price. And so what does this mean? Well, this means that every quantity, the firm will not be able to cover its fixed costs, or its variable costs, sorry. The firm will not be able to cover its variable cost of production, no matter what they do to try and minimize costs. And if a firm can't cover its variable costs, like labor or something, then they have to shut down. It's not economically feasible for them to continue producing uh, with that amount of loss. Okay, so the other scenario, well, when would you continue producing at a loss, right? Because you might say, like, well, the firm's losing money. Why would they ever continue producing? Well, we're going to see here. So let's draw this graph again. This is good practice. You can draw them out on a piece of paper anywhere. It's just good practice to do. So you have Mr. Darb, and then you have the marginal cost, and then you have the average total cost, which is still above price. So this will still be a loss, but the difference here is that the average variable cost is going to be below price when MR equals MC. So this will be the quantity produced, and then this will be the price again. Okay, and so here the firm is earning a loss. Yes, that's true. However, and this is the loss, this would be the loss. Same way to identify it as over here. However, in this example, the firm is covering its variable costs. And as long as a firm can cover its variable costs, it can continue producing. It's economically feasible to do so. And so that's what they should choose to do. Okay, and those are that. And then I believe the next slide is either going to be talking about long run or the actual market itself, but we will see. Okay, the industry graph, that's the market. So how does a firm determine its price, what it sells the units for? Well, the industry graph is where this comes in really. So you have the quantity and the price. This is the same for the industry graph. And this is going to be a lot like a graph you'd see in Unit 2 or Unit 1. I mean, it pretty much is going to be the graph that you see in Unit 2 or Unit 1, where you have upsloping supply, and then you have downsloping demand, and then the equilibrium price and quantity will be where these two intersect. And you guys have probably seen this a lot in Unit 1 and Unit 2, and it's back. So now let's draw a firm graph side by side. So we have the quantity, the price, and once again, this is still good practice. And then, actually, I won't draw it. So how do we know where this firm has a price? Well, it's based on the industry because there's so many firms, they're going to be a price taker from the industry. So where is the price? Well, that price is going to be where the industry price is. So this firm is going to have a price there. So there, Mr. Darker, MR equals AR equals D and equals P. Well, that's going to be the same price as the industry. Okay. And that's pretty much what you can tell from the industry graph. And the marginal cost curve, average variable cost, average total cost, they're still going to be the same, but I will draw them in quickly for a firm that is earning positive profit. There you go. This firm would be earning positive profit, as you can tell, because the price is above the average total cost, where MR equals MC. So it's a positive. Okay. So let's remove these. And then the next slide should be talking about the long run graph for this firm, or for, well, for all the firms in this industry. Okay. So what does a long run graph look like? Well, in this industry, and most of the other imperfect industries, which are in Unit 4, the the firm is going to be earning normal profits, or when economic profit equals 0. So there's still going to be the Mr. Dark curve. So MR equals D equals AR equals P. But the difference here is that it's going to be earning normal profits. So if a firm is earning normal profits, well, then the average total cost has to, well, the firm has to operate where the average total cost equals the price, because then P minus ATC would equal 0, and so there would be 0 profit. So we can draw a marginal cost curve for this example, and then we can draw an average total cost curve for this example, where it would be like this. I mean, the point is that this should be touching here. And so this firm is earning no profit. And pretty much what this means is that because all the firms are earning no profit, no firm has an incentive to enter, so no new people will be entering the market as a firm. And also, no current firms will be leaving because there's no reason to leave. Okay. So, that's all I have for you guys. Thank you very much for watching, and if you would like to see more micro or macroeconomic content, please let me know and let me know if this was helpful. Thank you.